All right, let's go ahead and do this next page. We have an ideal gas. And one thing I want to be clear on is let's talk about what the graphs look like, and that's going to come from the equation Pivnert. So just so you know, P is proportional to T, and V is proportional to T. So just so you know, the P versus T graph is going to be linear. The V versus T graph will be linear for an ideal gas. Now, assuming here that we're in centigrade, it actually turns out choice A is the correct choice. And the reason is the pressure at 0 degrees centigrade should be bigger than 0. If this were the Kelvin scale, it actually turns out that the pressure goes to 0 at negative 273 Kelvin. The other thing is that P and V, if you do a P versus V graph, it actually turns out that the graph looks more like this. That's what happens as the volume gets bigger, the pressure goes down, and vice versa. Just so you know. Now, and it's assuming fixed temperature. Now, which of these is not the assumption of the ideal gas model? Just to be clear, all of these statements are true, but this assumption here has, well, this rule here has absolutely nothing to do with how ideal gases behave. It's actually a consequence of some of the assumptions in the ideal gas model when you're doing thermodynamics in an advanced class, but it's not actually part of the ideal gas assumptions. And then this one here, let's be clear. If we're exchanging heat, so these are three different bodies at three different temperatures, theta x, theta y, theta z. The arrows represent the flow of heat. So clearly, we know that theta y is bigger than theta x, and we know that theta z is bigger than theta x. That's how those temperatures are. We don't know what the relationship between theta y and theta z is. So any of these choices that wants to use theta y and theta z mathematically, we can't say anything. So that rules out choice A and choice B. Now for choice C and D, let's see. Theta y bigger than theta x? Let's see. Well, heat flows from y to x, so yes, that's true. What about D, just to eliminate it? Theta x bigger than theta z? No, it can't be because it's the one receiving the heat. So that finishes up our multiple choice section, and we'll work through the paper 2 questions in the next video.